All right, welcome back. This is section 1.3. We're solving equations. We're reviewing and we're previewing for some other stuff. So, I don't know. I'm going to let the reader just kind of read this along here. And interesting. I find it interesting, but it's really some definitions and some odds and ends here. And what is a domain? Okay, so and so we see here customary to use letters at the end of the alphabet for variables. Okay, um, and at the beginning of the alphabet for used for constants. So ax plus b, x is our variable, a and b are our constants. All right. So just this is just reading, right? Constants, variables, are domain. I mean, one thing to think about the domain is like for here, the cardinal sin is you cannot divide by zero. Okay, don't do that. And one thing that'll make this zero is if x is one. Okay, that's bad. And if if t were 1 and t were -3, that would make this whole thing 0. So that's bad. And and then we have also here that -1 right there. Well, you can't have that makes the x into the denominator because this is the same thing as 4x um, plus 3. What is it? Plus 3 over x, right? And if x were 0, then that's bad. That's why it can't be 0. Okay, so we got these kinds of things. And we're moving along here pretty quick. Linear equations. I mean, well, linear equations, they just make straight lines when you graph them. And a critical element is it's a first degree. So the exponent on the x is just a 1, and it's absent right there, right? We don't even see it because when there is no exponent, you're assuming the exponent is 1. Okay, great. So these are all linear examples, and that's because the exponent is 1, the exponent is 1, the exponent is 1 on each of these. If you have a variable in the denominator, the exponent is -1, so not linear. Um, so uh, probably worth saying that with any equation involving a variable, each of these equations is neither true nor false until we replace a variable with a number. And the solution or root of an equation in one variable, we mean the value of the variable that makes the equation a true statement. Okay, so I mean, this is like old hat stuff, right? So we also have the idea of the identities. So this is what, difference of squares, if you remember from algebra 1, and same thing. And then here, the 1x will cancel each other out, and it's just x. So there you go. I mean, these are this is quick work here. Um, not much to say about this. We have a conditional equation is true for only some, maybe even none of the variables. Two examples of conditional equations are 2x equals 10 and x equals x plus 1. The first case is 5, right? Because 2 times 5 is 10. And the second case, it's never true because you can't have some number is the same thing as that number plus 1. All right, so we have elements here. I mean, this is such old hat. You can add, subtract on both sides, multiply or divide by both sides. Simplify an expression on either side, and the equation produces the same thing. This is just I'm just flying through this. This is the I mean this should be pretty easy, and they show you that solution down here, and this is quick work here. What they do, they simplify the left hand side, so they distribute -2 to both items. -2x, -2 times 1 is -2. What they do, 1 minus 2 is -1, and then they distributed the 3. 3 times -1, 3 times -2, and then they added x to both sides. So if you add that x to both sides, you get -5x. Maybe you would add 3 to both sides, and you would get 5. Divide by -5, and you get -1. This is just, oh, and then you can check this. What's wonderful is you can check it. So this -1 gets put in for x right there. And so when you do so, you're checking here. You know, when all the math here, basically you end up with 3 times 1 is the same thing as 2 plus 1, so you get a true statement. There's your true statement, 3 equals 3. And I mean, these are also called literal equations right here. Do this beginning in algebra, and you're solving for x. So they look kind of weird. And then you're plugging it back in, you get a true statement in the end. I'm not going to labor this too much. I'm going to spend more time on the activities, really. Um, these are kind of interesting. So what we can do is a common strategy with fractions multiply through the least common denominator. And so what they're talking about is this. I'll do it over here. Well, maybe I don't. Maybe I don't have to, because I'd like to spend more time on the exercises today. So we have this, and this. So the least common denominator is going to be this both product, because this denominator has x minus 3, and this one has x plus 5, obviously, and this has both of them. So that's the least common denominator right there. Nice. What I do is I just kind of see, okay, if I multiply everything by this, we have this right here, and I multiply that by the entire denominator right there. Okay, these are going to end up crossing out, which is going to be great. And then we have this. Actually, I wouldn't cross those out, would I? So right here we have 1 right here, 1. There's 1. It's hiding, but 1 times the whole denominator, which is why that's up there. And then 2 times the entire denominator right there. Boom. Okay. So what happens now is, yes, things do cancel out. These will cancel out. These will cancel out. And what are we left with? We're left with x minus 3 equals 2 times x plus 5. Nice, that's right there. And then these all cancel out, and this is right here. And then the rest is super easy. You just distribute right here, and then you can combine your like terms, and 10 plus 2 is 12. And then subtracting 4x over here. Did they? Yeah, subtract 4x leaves you with negative 3x minus 3, and then adding 3 gives you 15. Divide by negative 3 is negative 5. Blah, blah, blah. And we have our check, which is kind of interesting here. It shows that if the equation has a solution, then the solution is x is negative 5. With x is negative 5, however, the left-hand side of the original equation becomes that, or 1 divided by 0, which is undefined. We conclude, therefore, that the given equation has no solution. Okay, so that is definitely worth a check right there. Yeah, that's a good point. So when we do this, we actually don't have a solution. There is no solution to this, even though we got that. If you plug this back in, so what they're saying, if you plug that back into here, you get an undefined fraction in here too. So you're in big trouble. So there is no solution to that. Always interesting. So in example 2c, what we just did, x is equal to negative 5, which does not check in the original equation, is called an extraneous root or extraneous solution. How is it that an extraneous solution was generalized in example 2c? We multiply both sides. We didn't know at that stage that the quantity was non-zero. We could not be clear that the resulting, I mean, this is just kind of, we restate this advice in the box that follows. Okay. Multiply both sides of an equation by an expression involving a variable may introduce extraneous solutions. So in our problem set, we're going to have to start looking for those extraneous solutions just in case. So you definitely want to check your solutions. Therefore, it is necessary to check any candidates for solutions that you may obtain in this manner. Okay. So we solve this one here. I mean, this is another. So they're telling us that okay, c plus d is not equal to 0. Yeah, you need that. And y minus ca is not equal to 0. And they're telling us that because when you solve the whole thing, you get this right here. And you should check for yourself that the expression for x on the right-hand side of this last equation indeed satisfies the original equation. So they're saying, plug this back in, check it, it should work. So interesting. The old quadratic equation. Okay, anyone that's been through Algebra 1 has seen that. So the quadratic equations mean that you have a 2 for an exponent right there. So these are quadratics. And we're going to, in solving these, it looks like in this case, they, let's see, here, for this one here, equals 10x. Oh, okay, so they brought everything to the same side. They found that they could factor it. Good for them. And you set each of the factors equal to 0. Okay, and you get your solutions. And then you could check it by putting it back, both back in. Using the different squares, you can. Oh, yeah, that's rather interesting right there. Oh, different. Okay, so this is a different kind of question. I was confused for a second, but yeah, they have a different one. So difference of squares, yeah, means one's minus, one's plus. Set them each equal to 0. Okay. Here's another perspective. Example 4b. Okay, instead of using the factoring to solve that, we can instead write this. So if we have 4x squared minus 9, if you add 9 to both sides, right? So if you have 4x squared minus 9 equals 0, and if you add 9, you have 4x squared equals 9. If you divide by 4, x squared equals 9 over 4, which is right there. And then you take the square root of both sides, and then you have 3/2. So, as they say here, this is important. By looking at this last question, we can see that there are two solutions. You know, because when you take the square root, you have a positive and negative root. Those are the only two numbers with absolute values of 3/2. We abbreviate these two solutions by writing plus or minus 3/2. Okay. In practice, we usually omit showing the step involving the absolute value. For example, to solve the equation that, we just write x squared equals that. Then taking the square root, immediately you get the two solutions of plus or minus root 2 over 3. Because you can take the square root of 2. I'm sorry, you can't take the square root of 2, but you can take the square root of 9. Okay, sounds good. But as I said, not all quadratic equations can be solved by factoring. And when you can't, you use this quadratic formula. A marvel of algebra. And this is, again, this should be old hat. Easy peasy, lemon squeezy. Finding that you have A, B, C. A is 2, B is 4, C is negative 3. So A is 2, B is 4, C is negative 3. And then you just substitute all that. Here's our formula. And you substitute the A, B, and C into here. And then you simplify it all. And that's it. Oh, boy, students always want to do this too. They want to do that. And you can't do that. That's a big no-no. You would have to have, in order to do that, you'd have to do a 2 here and here, and then you can cancel those out. But otherwise, no. Let me erase that. Okay. So, techniques reviewed in this section: solving linear and quadratic equations. Okay, and we will see these applications throughout the book. So so we also have polynomials. Okay, a polynomial has the form of this, where it has the highest degree and then a lower degree all the way down to 0 degree. And so this, and they're usually written, this is what called descending form. So it's the highest exponent, then a lower exponent, then it is, this is actually x to the 0, right? X to the 0 right there. X to the 0, because anything to the 0 power is 1. So um, so you got all that, and yeah. So this is descending, 3, 2, 1. Okay, 4/4 is bigger than 2. It's bigger than 1. It's bigger than 0. So that is all descending order. And they talk about the degree and how you determine that degree. It's really the largest exponent. Okay, so here, unfortunately, not all polynomial equations are easy to solve, as this last one here. Okay, uh, and later on, chapter 12 contains complete discussion of polynomial equations. So that's towards the end of the book, though. Let's get into some exercises. So I'll pick a sprinkling of a few of these. Maybe I'll go into number 6 first. So verify that the numbers. Okay, so we have this quadratic, what, x squared minus 2x minus 4 equals 0, and I need x to be 1 plus the square root of 5. So 1 plus the square root of 5 squared minus 2 times 1 plus the square root of 5 minus 4 equals 0. So I need to expand this out. Foiling, crab method, whatever. That's 1 plus the square root of 5 times 1 plus the square root of 5. What is this? This is 1 plus the square root of 5 plus the square root of 5 plus 5, right? And then if I distribute that, that's minus 2 minus 2 times the square root of 5 minus 4 equals 0. And this is 1 plus 2 times the square root of 5 plus 5 minus 2. Minus 2 times the square root of 5 minus 4 equals 0. And then these cancel each other out. What? Then what we have is 1 plus 5 minus 2 minus 4 equals 0. And this is 6 minus 2 minus 4, which is absolutely 0. So I did it. Okay, and then how about the other one? The other way too. We have continue with number 6. It is, once again, it is x squared minus 2x minus 4 equals 0. And it's 1 minus the square root of 5 squared minus 2 times 1 minus the square root of 5 minus 4 equals 0. So this would be what? 1 minus the square root of 5 minus the square root of 5 plus 5. That, I just squared the whole thing. What, minus 2. Now I'm distributing. 2 times negative 1 is negative 2. And then negative times negative is positive. So it's plus 2 times the square root of 5 minus 4 equals 0. And this is minus 2 times the square root of 5. And I have 1. And then plus 5 minus 2. Plus 2 times the square root of 5 minus 4 equals 0. These will cancel again. I have 1 plus 5 minus 2 minus 4, which again is, of course, 0, because that's 6 minus 6 equals 0. Okay, so I showed that that worked. Let's solve something that And number 11 looks a little interesting. Let me erase this stuff here. And for number 11, let's see. Number 11, that's t minus, that's a curly brace, 4 minus bracket, t minus 4 plus t, close parentheses, close brackets, close curly braces, equals 6. Okay. Now, you don't see the curly braces all that often, but really what we're dealing with is parentheses, brackets, curly braces all mean the exact same thing. I think that it becomes easier to organize because if everything were parentheses, it might be hard to see where it ends, where it begins, since there's so many. So there you go. To begin with, this negative needs to get distributed to each here. So it's t minus 4 minus t. Okay, so that's taken care of. It's 4 minus this t. Okay. And then this negative gets distributed to each item here. So it's t minus, that's a terrible curly brace. So it's 4 minus t plus 4, right? Because negative times negative is positive, plus t, because negative times negative is positive. Whop. And it looks like these t's cancel each other out. And we're left with 4 plus 4, which is 8. So it's t minus 8, right? Which is really just t minus 8. And that is our answer there. Okay, let's get to, okay, let's do 14 and then 16. So 14, usually these even numbered questions are harder than the odd, and the odds are, the answers are in the back of the book. So we have x minus 1 over 4 plus 2x plus 3 over negative 1 equals 0. Let's multiply everything by negative 4. I realize actually it could just be 4. So I'll do everything by 4. A unique case. So what happens? If I do 4 times that, the 4's cancel, and I'm left with just x minus 1. Okay, if I multiply this right here, that is plus 4 times 2x plus 3, all divided by negative 1. And then 4 times 0 is 0. And so we have x minus 1 plus 8x plus 12, all divided by negative 1 equals 0. And if you divide by negative 1, that really changes the sign of everything. So we have x minus 1, minus 8x minus 12 equals 0. And then we can have, well, let's combine this. This is negative 7x, and these is minus 13 equals 0. And then here comes the easy part. Negative 7x equals 13. So x has to be 13, negative 13 sevenths. Try it again. Sevenths. Okay, not so bad. 14. 18 looks kind of fun. So let's 18. Looks like it'll probably be satisfying because we got difference of squares. So on number 18, we have 1 over x minus 5 plus 1 over x plus 5 equals 2x plus 1 over x squared minus 25, which we should see is x plus 5 times x minus 5. Okay, and so what should we multiply everything by? We should multiply everything by x plus 5, x minus 5. So multiply this all by x plus 5, x minus 5. Okay, So when I do that here, the x minus 5's cancel, and it's 1 times x plus 5. And then I have, oh, I just thought of something. And then plus, multiply this here, and the x plus 5's cancel, so it's 1 times x minus 5. And then on that one, it's just going to be 2x plus 1 because everything cancels. So we have x plus 5 plus x minus 5 equals 2x plus 1. So you have 2x, and then the 5's cancel, equals 2x plus 1. Hey, there is that, this won't work, right? Because if we have, I mean, if I were to do this, I get 0 equals 1, which is certainly a false statement. And that means there is no solution to that one right there. Okay, super. Let's take a look at what else we got in store for us. Let's get into those, like some in here, like number 30. Let's solve by factoring. So on number 30, I gotta make this a little bit smaller here to give myself some more room. So for number 30, we got x times 2x minus 13 equals negative 6. So solve by factoring, we need to have everything on the same set. Well, I'll distribute. And we get what, 2x squared minus 13x. And then if I add 6 to both sides, I get plus 6 equals 0. And then we have to figure out, well, what will do this? Let's see. The first one has to be 2 and x. So you have to multiply to get me 2x squared. And then 3, 6. Oh, yeah. So this would have to be, what, a 6, and this would have to be a 1. Right? Because 2 times 6 is 12, plus 1 is 13. And they would both have to be minus like that. Okay, great. I did it. And so basically, when you multiply these two together, you should get this. And let's see. So then you separate them to x minus 1 equals 0 and x minus 6 equals 0. So x has to be 1/2, and x also could be 6, right? Because if you had 6 to both sides, you got that. And yeah, there's 2 solutions on that one. Not so bad. You know, number 33 is just begging for a little love. It looks like it's kind of angry. So let's see now. So we have x squared plus 2 times the square root of 5 times x plus 5 equals 0. Oh, yeah. So this would be the square root of 5. So this would be x plus the square root of 5, and I think that would be squared equals 0. Yeah, because if you multiply, this times itself is 5, and this plus itself is 2 times the square root of 5. So there you go. Now, if we were to then take the square root of both, the square root of 0 is 0. The square root of that is going to be x plus the square root of 5. So we then subtract the square root of 5, and x equals the opposite of the square root of 5. Okay. And I don't have to worry about any domain, no fractions that denominator of 0. So that's not so bad. Quadratic formula, geez, that's really easy. Like if you have number 36, that's what, if you distribute, that's x squared plus 6x, and then if you add the 2 to both sides, it's plus 2 equals 0. So a has to be 1, b has to be 6, and c has to be 2. So it's the opposite of b, plus or minus the square root of b squared minus 4ac all divided by 2a. So the opposite of b, so it's what, negative 6 plus or minus the square root of b squared, which is 6 squared minus 4 times a times c. Okay. All divided by 2 times 1, 2a. So that is the opposite of 6 plus or minus the square root of 36 minus 8, right? All over 2. So that is negative 6 plus or minus the square root of 36 minus 8. I think it's 28. All over 2. And so that's equal to negative 6. The square root of 28 is the square root of 4 times 7. And the square root of 4 is 2. So that's 2 times the square root of 7. Okay. So that would be plus or minus 2 times the square root of 7 all over 2. I think that's where we could end it right there. Maybe not, because it looks like, you know, you can divide everything by 2, divide that by 2 and that by 2, and you're good with that. So it's negative 3 plus or minus the square root of 7. That's probably where we would finish it. And then if you put it in a calculator, you'll get a decimal answer. So we got a heap of questions here. Look at all this wonderful stuff. How about I'll skip down to maybe 53. I'll go down to 53 here and solve each equation in terms of the other letters. So 53. Yeah, this is going to be these are called literal equations. So 1 over x equals a plus b. I would multiply everything by x. Multiplying that by x, the x's cancel, and you have 1 equals x times a plus b. Just kind of leave it like that because I'm trying to solve for x. I wouldn't just distribute. Keep it like that because now I would divide by a plus b, and 1 over a plus b is equal to x. Okay, not so bad. Maybe I'll jump to number 58 to keep things spicy. Number 58, we have x minus p squared plus x minus q squared, and that's supposed to be equal to p squared plus q squared. Okay, so if I FOIL all this, this can be a little bit easy. So that's x squared minus, so x minus p squared is x minus p times x minus p. So this is x squared. That's where my x squared came from. And then this is minus px. This is minus another px. And this is plus p squared. So that's x squared minus, this is minus 2px's, right? Minus 2px's plus p squared. And then the x minus q, we could probably use a similar pattern here. That's going to be x squared minus 2qx plus q squared equals p squared plus q squared. And at this point, you're usually hoping that something cancels out. So the q squareds will cancel and the p squareds will cancel. What we're left with is x squared minus 2px minus 2qx equals 0. That's kind of nice. Oh, and I just realized right here we have x squared plus another x squared. So that's 2x squareds, right? If we divide everything by 2 and divide that by 2, what we're left with is x squared minus px minus qx equals. So we have this whole thing right here equals 0. Okay, so I'm going to erase some stuff here. And so what we got is a little factoring job here. So we can factor out an x from everything. So we have an x. what, x minus p minus q equals 0. So x could be 0, and we would have x minus p minus q equals 0. So if I add p, oops, p and q, that's supposed to be add p, add q, x would be p plus q. Or x could be p plus q. And that, yeah, that was a little spicy on that one. Not so bad. Okay. We have some other questions here. Let's see. Yeah, this whole section only goes, there's no C section to this. So this is mildly interesting. Maybe we'll go for 66. So we're supposed to solve for y. Just y. Not y sub 1, but y. So let's see how this one goes. X sub 1 times x over a squared plus y sub 1 times y over b squared. It feels like a formula. I don't recognize it though. So I want to multiply everything by a squared b squared. So if I multiply everything by a squared b squared, what we're left with, if we distribute here, a squareds cancel, so it's b squared times x sub 1 times x plus a squared, a squared times y sub 1 times y. Okay, oh, and that has to be b squared right there, equals a squared b squared. Now you got to remember, we're trying to solve for y, right? So if we would want to subtract b squared, x sub 1 times x, minus b squared, x sub 1 times x. So what we're left with is a squared times y sub 1 times y equals a squared b squared minus b squared times x sub 1 times x. And we should be able to get the solution. So it's really just everything's being multiplied here. So if I divide by a squared times y sub 1, divide this by a squared times y sub 1, then that's it. Y has to be a squared b squared minus b squared times x sub 1 times x all over a squared times y sub 1. Yeah, not so bad. Let's go with, what are they asking for in this one? They're saying solve the equations. You may need to multiply both sides by expressions. Remember to check your answers. Okay. I'm going to have to do a couple of these here. So let's go. Let's just go with number 70, I guess. Starting with number 70. Let's see. I'm leaving the easier ones for you guys. So erase all this stuff here so I have plenty of room. I'll do a few of these down the stretch here. So we have number 75 over x plus 2 minus 2x minus 1 over 5 equals 0. So multiply everything by 5 times x plus 2. Okay, so if I do that here, I just have 5 times 5, right? Because the x plus 2's cancel, so that's 25. Minus, the 5's cancel, so it's 2x minus 1 times x plus 2. And then if I multiply that here, then that's going to be 0. So I don't know, I want to be safe with this. So 25 minus, I'll put this in brackets, and I'm going to distribute the what? That's 2x squared plus 4x, right? Minus 1x minus 2 equals 0. End of brackets right there. And so that means it's 25 minus 2x squared minus 4x plus 1x plus 2 equals 0. And let's put the 25 all the way down there. So it's negative 2x squared minus 4. Minus 4x plus 1x. That's minus 3x, right? So minus, oops, 3x plus 27 equals 0. Uh, boy, 9 and 3. It's begging to get factored at this point. So I'd like to I'd like to divide everything by -1. So I have my leading coefficient positive. So if I divide everything by -1, that really just changes the sign of everything. So that's 2. That's a weird looking 2. 2x squared plus 3x minus 27 equals 0. Okay, let's see if I can figure this one out. 9 and 3. 9 times 3 is 26. So this is going to be 2x and this is x. Those are my only choices. 9 and 3. Yeah, I gotcha. So it's going to be 9 and this is going to be 3. And I want it to be positive. So it's going to be plus 9 and minus 3. Okay, so x can be 3, or x can be what, -9/2. And so they're saying check your answers. Okay, so I'm just going to hold on to that, and I'm going to erase all this stuff, maybe just up through here, maybe. Okay. And then I'm gonna erase this here too. I don't really need that. I don't really need these brackets. Oh, it's not erasing. Oh, I see. So brackets erased, and this has to be a 5 still. And I'm saying that, oh, okay, if x were 3, oh, this is going to be pretty easy. So if x were 3, that'd be 5 over 3 plus 2 minus 2 times 3 minus 1 over 5 equals 0. So yeah, this is going to be 5. I'm not going to, who cares if the numerator. And then the other one, if you have -9/2, so 5 over -9/2 plus 2 minus 2 times -9/2 minus 1 over 5. This is not a problem because I'm not going to get 0 in the denominator anywhere, so we're good. Both of these work as solutions. Let's try to find one that they're going to try to trick us on this now. I'm feeling like maybe 74 might do it. So number 74. Let's see. 2x. Oh, let me erase the answer to this too. So, okay. So 2x over x squared minus 1 over x plus 3 equals 0. So multiply everything by a lot of stuff. You have to multiply it by x plus 1, x minus 1. Do you? You don't. But no, you don't. I was going to do, because x minus 1, x plus 1 is x squared minus 1. And you kind of don't have to do that. So I think I'm going to avoid that. And just call the least common denominator x squared minus 1 and x plus 3. Right? So then when you distribute, this is going to be 2x times x plus 3 minus, and then when you distribute here, the x plus 3's cancel. This would be 1 times x squared minus 1, and then that all equals 0. So then this would be 2x squared plus 6x. That's supposed to be an x. Minus x squared, right, plus 1, because if you distribute to each of these, negative times negative is positive. Anything I can clean up? Yeah, this is 2x squared minus x squared is just x squared, and then 6 plus, oh, no, you can't do that. Plus 6x plus 1 equals 0. Whoa. And I pause for a moment because I'm not going to be able to factor this. It's going to have to be a quadratic formula. So A equals 1, B equals 6, and C equals 1. So that would be the opposite of 6 plus or minus the square root of 6 squared minus 4 times 1 times 1 all over 2 times 1. Okay, so it's negative 6 plus or minus the square root of 36 minus 4 over 2. So that is negative 6 plus or minus the square root of 32 divided by 2. And I could go further with saying that this is, let's bring this up a little bit. So this is negative 6 plus or minus, well, the square root of 32, the square root of 32 is the same thing as the square root of, what, 16 times 2, which is 4 times the square root of 2. So it's negative 6 plus or minus, instead of the square root of 32, it'd be plus or minus 4 times the square root of 2 over 2. And now we can, that can divide, so it's negative 3 plus or minus 2 times the square root of 2. Whew. Okay. So let's see where we're at now. And I don't really see any restrictions. I mean, the only thing that we can't have is we can't have x be negative 3. Okay, it's not going to be. And we can't have x be 1. It's not going to be. So both of those solutions, because we're looking at two solutions now. We're looking at the idea that we have negative 3 plus 2 times the square root of 2 and negative 3 minus 2 times the square root of 2. I feel a little bit cheated that everything worked. Let me see. What else? Okay, the last one I'll do is number 73 for poops and giggles. Let's see what we got here. So for number 73, we have x over x minus 2 plus x over x plus 2 equals 8 over x squared minus 4, which is the difference of squares, which is x plus 2 and x minus 2. And so what we'll do is we'll multiply everything by x plus 2 and x minus 2. So distributing to the first one, the x minus 2's cancel, and we get x times x plus 2. And then doing that one, the x plus 2's cancel, and you get plus x times x minus 2. And then everything cancels, and we just have 8. Okay, well, that's nice. Then what we could do is we would have, so if I distribute, I get x squared plus 2x plus x squared minus 2x equals 8. So this is 2x squared, so putting these two together, the 2x's cancel. 2x squared equals 8. So that's also the same thing as 2x squared minus 8 equals 0. If I factor out the 2, I get x squared minus 4 equals 0. And if I divide both sides by 2, these cancel. So that's x squared minus 4 equals 0. That's difference of squares. So that means it's x plus 2, x minus 2 equals 0. So if you solve separately, you have x plus 2 equals 0 and x minus 2 equals 0, which puts us at x can be negative 2 and x can be positive 2. And we were told to check. So let's check this. If x were negative 2, then this would be 0, which is bad. And then that would be 0, which is bad. And we cannot, that won't work. This whole thing, you can't even divide by 0. And if x were 2 here, that would be 0, which is bad. That would be 4. Okay, but then this would be 0, and that's bad. So uh, neither of these are the solution. So I guess we just kind of go with there is no solution. And so there you go. Nice little review. Not so tough on this, but definitely work through those exercises and let me know how it's going. Till next time, for the next lecture, which will be rectangular coordinates. Bye.